Every so often, you find yourself needing to support virtual machines in situations that go beyond just simple high availability. Maybe you got a database that is particularly important to your company. Maybe all your resources need to have some disaster recovery built in. Well, in those situations, you have a couple of new functionalities that we're now seeing with Server 2012 and 2012 R2 that support some real workable ways of doing site level fault tolerance. Now, the word fault tolerance here, the term fault tolerance, can be a little bit of a misnomer because fault tolerance, depending on which vendor you refer to, can have a little bit of a different meaning. So VMware's fault tolerance is a little bit different than what Microsoft's fault tolerance is, but they kind of share the same core. When I'm talking about fault tolerance, I'm talking about a level of availability that goes beyond just being able to fail over from one host to the other. That supports most of the situations that are out there, being able to have that virtual machine come back online. But in the situation where I have a very highly important virtual machine, there comes the time sometimes to create additional functionalities or to add additional technologies that support these extra use cases. Now, in this nugget, we have really two kinds of use cases that we're going to focus on. And these two use cases focus on the loss of a site, so the complete loss of an entire city, for example, in one case. And in the other case, we're going to talk about being able to have multiple virtual machines that are replicated in lockstep, that are available so that you can power on an alternative virtual machine very quickly without having to worry about restoring them from backups. In the Server 2012 R2 world, we think of this as Hyper-V Replica. Now, Hyper-V Replica, again, this is not like what we had before with Windows failover clustering. And Windows failover clustering, when I ended up creating a cluster with two hosts that were connected into central storage, and I created some kind of live or initiated some live migration from this host over to this host, remember, the virtual machine never moves. That virtual machine stays in a single location. In the situation where I want to have a second copy of the virtual machine, it is in this instance where I can create either on a cluster or not on a cluster a situation that involves Hyper-V Replica. Now, in this case, in addition to being able to fail over the virtual machine, there is also some sort of replication activity that's going on between one set of storage and another set of storage. Now, what's most important about this is that the Hyper-V Replica that you see here in Server 2012 R2 is designed to support even the use cases across extended distances. So yeah, it's going to take a pretty long time to get that first virtual machine migrated over to the second, the second area of storage. But once you get that virtual machine migrated over, in all but the most ridiculous of use cases, the additional updates, the changes that occur on an every few minutes basis, those changes are going to be relatively small. And so the network pipe that has to happen between these two locations after that initial synchronization is complete is going to be quite a bit less, orders of magnitude less than is required. In this nugget, we're going to talk about how you can implement Hyper-V Replica between two Hyper-V hosts. So let's assume this is not part of a cluster. We will also talk about how to implement Hyper-V Replica between clusters or among clusters. So you have a lot of options here depending on which of the technologies you want to lay into place. Obviously, having it on a cluster requires a little bit of extra work. That extra work, part of it is involved with actually implementing a Hyper-V Replica broker service, a highly available role on top of the cluster. You typically install this service on any cluster that you intend on participating in Hyper-V Replica, any replication work, and it's got the job of making sure that all the bits and bytes make their way over to the alternative location and brokering, hence the word, that the communication path between the two environments. Now, in R2, we also have this other thing here called extended replication, which really extended replication is just a replication plus one. You can think of it that way. In extended replication, if I create a replication connection between two different machines, so I have a virtual machine here that's being replicated at this location, all extended replication is the ability to create another replication relationship between the replica, the target machine, and some other location. That's all we're talking about here with extended replication. And the most important thing that you have to know for this topic is in recognizing that extended replication gets initiated, gets created from the target location, so from the very first target location. Once you do the first hop, extended replication takes care of doing the second hop. We'll spend a pretty good amount of time talking about Hyper-V Replica and going through an extended demonstration of Replica a little bit later on in this series. But I want to talk also about a very different type of fault tolerance that you can incorporate in for your Hyper-V machines, and that's multi-site clustering. Now, multi-site clustering is a particularly complex implementation of clustering that, as it says, aggregates that cluster or connects that cluster across multiple geographic sites. So let's assume, for example, that we have a 2-node cluster here, again with its storage, and we're plugged in here. And we have another, perhaps 2-node cluster sitting over in some alternative location. And these 2-node clusters here, these two 2-node clusters, are connected in a way that makes them a single cluster of 4 nodes. This is the concept of multi-site clustering, because I may over here in the Denver site have a couple of nodes, and over here in the Las Vegas site have some additional nodes. Now, implementing multi-site clustering adds a whole host of additional complexity into the management of your cluster for a lot of different reasons. First and foremost is the need to have some sense of replicated storage between the 2 locations. So you have to have that replicated storage between the 2 locations to support a multi-site cluster. And Microsoft does not really have any kind of tools to do that. You'll typically use some other solution, some third-party solution, to manifest the replication between those 2 locations. The implementation of that replication is something we're not going to really touch on for this series. It kind of goes above and beyond the Microsoft content and definitely the 412 content. But what we do want to talk about are the bits that you have to adjust as it relates to the cluster itself and the roles themselves. As you can imagine, anytime we're dealing with cluster roles, we've got some interesting things we have to deal with, like quorum, like network settings, and like failover settings. Now, in previous versions of Windows clustering, back before 2012, a cluster had to, all the nodes in a cluster had to exist within a single subnet. And that was done for a lot of reasons, a lot of actually at the time smart reasons. So having it in a single subnet means that you have a single namespace, a single IP space that exists between these 2 locations. The hard part, however, is from the networking side, so not you but your Cisco people, actually extending a single subnet across multiple geographic locations is a bit of a challenging task to do. And so in 2012 and also in 2012 R2, we now have the ability to have different subnets for different locations. And this is more akin to what you see in most production environments. So our 1net, our 2net, for example, or whatever network we have between these 2 locations. The implication of that, however, starts here with the network settings. Imagine, for example, that you have a virtual machine that's sitting over here in Denver, and that virtual machine is set up with a 192.168.1.225 net address. Well, that virtual machine, when you're thinking about the failover settings for that virtual machine, the idea of a failover site is probably intended for that site to only be used in the situation where the entire primary site goes offline. But that entire offline status, so that when Denver gets nuked, is something that doesn't really happen all that often. And so for most everyday operations, you probably just want this virtual machine to end up failing over back and forth between the hosts in its home site, and to only ever go over here to Las Vegas in that very rare situation where the entire site goes away. Because of that, we have to make some very specific settings here to, number one, how we prioritize failover. Right? I want to make sure it goes here to the local site first and only over here if I've got a site failure. That's the number one thing we have to deal with. The number 2 thing we have to deal with is in recognizing that if we should move this virtual machine over to this site, and it ends up moving over here because Denver is no longer existing on the map, well, this site is a 2.0 site. And so the virtual machine now is going to have a 192.168.1.225 net address that's not going to route in my 2.0 subnet. And so we have to have some way of injecting a 2net address into the virtual machine after it moves into the alternate site. Also is important is recognizing that when we have multiple sites, we also change the way that we need to think about our quorum and how we end up distributing the votes that determine who actually still is a cluster in the case of a loss of an entire site. This determination of quorum is something that is probably the hardest part about a multi-site cluster configuration, because you have to protect yourself against the loss of a server, but you also have to protect yourself against the loss of a site. And you want to accomplish this without ending up in a situation where, well, maybe I've not lost a server or a site, but I've just lost communication between the two halves of the site. And I want to protect myself against the situation where either of these two locations at the same time believes themselves to still have the quorum. This is a real challenging thing that we're going to talk about here as we get into the multi-site clustering bits a little later on in this nugget. Got a very quick thing here as far as multi-site failover and how to recover. There's just a couple switches you should be aware of. Then there's also this global update manager, which is literally just one command I want to point you towards. It's again, it's one of these test questions that you should be aware of. So let's begin by first talking about Hyper-V Replica and some of the new technologies that Microsoft has incorporated here in with Hyper-V that allow us to do some honestly cool stuff with Hyper-V virtual machines. So I've created two new servers. This is Clust4 here and Clust5. Now assume for just a minute that, I need to remove this. Assume for just a minute that these servers Clust4 and Clust5 are not actually yet members of a cluster. I don't want to pull these into that cluster just yet because I want to show you how the Hyper-V Replica service works without all the extra cluster stuff baked into place, at least to start out with. Let's assume that I want to create a virtual machine here on this server Clust4, and I want to create that virtual machine as a machine that will ultimately be replicated over to Clust5. Let's just create a new virtual machine here. I'm going to call it my replica. So this is just the name of the VM. I'm not dealing with any of the cluster stuff here, so I'm going to put it in the standard location for a standalone Hyper-V machine. Just set it up as a Gen 2 machine with 512 megs of startup RAM and give it a virtual switch here and a standard hard disk. I'm not actually even going to go about installing an operating system just yet because, I mean, it's nice to see the operating system, but for the most part, you really don't even have to have much in the way of an operating system on this virtual machine in order to start out dealing with replication. I'm just going to power on the virtual machine here at this point. It's going to power onto the BIOS and not really do much of anything. But what this does let me do is it lets me initiate the process of replicating this machine over to another Hyper-V host. Now, for us to be able to do that, we have to accomplish a couple of things first. Those happen here in the properties of the server itself under Hyper-V settings. One of the things I want to look at here is the replication configuration. This replication configuration is disabled by default. I need to enable it on any of the machines that are going to participate in replication, so both the source and the target. When I do that, then I have a choice of the types of different authentication that I can do between hosts that participate in the replica. So in one case, I have Kerberos. Kerberos is a very simple implementation. Kerberos leans on the existing Active Directory authentication that exists between these two hosts. Obviously, the two hosts have to exist in the same domain or in trusted domains, but if I turn on Kerberos, I'm done, and there's no extra work that's involved. Now, one of the limitations of Kerberos, however, is that Kerberos is just an authentication protocol. It's not used for encryption. And so when I turn on Kerberos, I'm not actually going to have encrypted data that's passing across the network between my source and my target. So I'm going to use port 80 here and not encrypt the data. Kerberos is easy, but it's not encrypted. On the other hand, if I want to use certificate-based encryption, I can then turn on encryption in order to support that. However, to use certificate-based authentication, I have to have a certificate that meets certain needs. These certificates I'm probably going to generate with my own internal CA, although you could use an external CA if you wanted to. The certificate needs to, let me grab my pen here, to be not expired, to have both the client and server authentication extended key usage enabled and also have an associated private key. It should terminate with a valid root certificate, and the common name on the certificate needs to contain clust4.company.pri. Over on Clust5, I need to have another certificate with all of these settings also configured, probably that corresponds to clust5.company.pri as well. Now, I don't have that certificate yet because we're not going to start talking about certificates until the next nugget. So don't worry, I'm going to show you how to create that certificate a little later on as we get into building certificates. But recognize that there are some rules here that you'll have to actually go through if you want to create that certificate. And there's some extra steps over in Active Directory Certificate Services that you're going to have to go through in order to actually provision that certificate. So hold on to that thought for at least a couple of nuggets so I can show you how to build that there in ADCS. For now, we're just going to use Kerberos because it's easy, it's unencrypted. I don't really care because this is just a test, and later on we'll backfill this with the certificate-based authentication. In addition to the authentication, I have to deal with the authorization as well, or essentially determining who will be able to be a replica partner. Number one, on one side, I can determine whether or not I just want to allow replication from any authenticated server. So any server in the domain is going to be allowed to replicate to or from this machine, Or I can choose to allow replication from specified servers. And for each, I can determine a storage location and a trust group for essentially a grouping of servers that virtual machines can move across. Now, keeping things simple here, I'm just going to allow authentication from authenticated servers. And this is going to enable things over here on Clust 4. Now, remember too, if you've got firewalls set in place, that you also need to have the appropriate firewall ports set up. And in this case, it's going to be port 80 for the replica HTTP listener. When I turn on replication, or when I turn on the replica bits over here, recognize over on my other server, Clust 5, that I'm going to have to accomplish the same thing. I've already done that here. Make very sure that when you configure these that you match the settings between the source and the target servers so that you end up having the right settings. Be aware that if you turn on replication for using Kerberos, the only way to get certificate-based authentication turned on is to remove replication, turn it on, and then reinitiate replication. So it's kind of a pain here if you don't set things up the way you intend to, at least in the beginning. And before I forget, the other really cool thing about certificate-based authentication here is that you don't have to be members of the same domain. So if your replica site, your alternative site, is a completely different Active Directory domain, certificate-based authentication will allow you to replicate into that location. So you don't have to have a domain traffic that's crossing very large distances. Let's go ahead and take our replica server here. As you can see here, there's nothing much to see. I don't even have an operating system just yet. And actually enable replication on the server. I'm going to replicate this server from Clust 4 to Clust 5. And I'm showing this because mainly I want to show you that the replication exists outside, most of the replication exists outside the whole confines of the Windows operating system itself. So I can set my replica server here, clust5.company.pri. It'll go through and verify the configuration and say, yes, you're going to use Kerberos authentication here. I do want to compress the data because I have to transmit it over the network. That's generally a good idea. I'm trading processor power for a reduced amount of network throughput that I have to have. I then identify which of the virtual hard drives, the VHDs, that I want to send across. This virtual machine only has one hard drive, so I'm just going to pick this hard drive here. And now I can identify how often I want the changes to be replicated from the source to the target. Obviously, the more amount of time that elapses between replications, the more data that's going to have to get sent across. So how bursty do you want that data to be? 30 seconds, 5 minutes, 15 minutes. I can also identify additional recovery points that may happen when I turn on this replication. Now remember, not every problem has to do with the loss of an entire Active Directory site. Well, no, sometimes there's corruption events that could occur. So in those situations, maybe I get a virus attack or maybe the database corrupts. It's nice to be able to go to my replica server and then go backwards in time and reverse the replication so that I have the ability to turn the clock back before the virus incident ever occurred. If you intend on incorporating these, I want you to be very careful about how you check this checkbox right here for VSS. VSS is a mechanism that ensures that your applications, those that register with VSS, are properly quiesced before a snapshot is actually taken. What this means is that if you have things like Exchange databases, Active Directory databases, SQL databases, anything that registers with VSS, these databases with a regular recovery point are going to require extra effort to get them back online. If you've ever had the situation where you accidentally pulled the cable out of an Exchange server and had to run the ESE util and the isntag and all that other stuff to get Exchange back functioning again, you know this pain. So the VSS snapshots are the ones that are application consistent and the ones that you probably are going to want to revert to if you have the opportunity to, because a VSS snapshot is an application aware snapshot. It's the ones where the databases are properly quietened before the snapshot actually occurs. So very important recognition here. Definitely check this if you end up setting up replication. I'll go ahead and do that here as well. I can set how many recovery points, 24 hours, and then every 4 hours for VSS. You got to be careful with these VSS things too, because VSS actually kind of has to pause those databases for it to do its work. The pause is infinitesimally small, like it's really, really short, and your clients really are not going to notice it in most situations, but it does create a pause there. So just be aware of that pause may have an implication in really overloaded situations. Now, when I told you when you create these replications, the very first synchronization takes a really long time because I have the entire contents of this server to send over to the remote site. Now this server is only, I think that the hard drive is 127 gigs in size, so it's not that big compared to the Exchange or SQL databases of the world, but it's still fairly large. Now that initial replication method can happen by just having Hyper-V Replica manage the initial replication for you. Alternatively, if you were to make a copy of that virtual machine and send that copy, you could use an existing virtual machine over on the target side as that initial copy. Now, you would have had to make that copy and export it and import it out onto that remote site so that it's available for this to be done. Or you can use some external media to do the same thing. The external media allows you to essentially export the virtual machine, drop it on a piece of media, and then mail that piece of media out to the remote location. In situations where you got servers that are terabytes in size, the USPS probably has better bandwidth than what you can buy through your average Comcast or whatever your internet provider is. I can also identify when that initial replication will occur. Okay, so when do I want that to start? Perhaps after hours. So again, be very conscious here of just how much data is going to get sent across for this first time through, because it's a lot. This virtual machine, because there's nothing to it, is very small. So the replication is going to go bam, like that, really, really fast. There it goes. And the replica has succeeded. We're not talking about pretty much any data at all. And so now you'll see over here on Clust 5 that we actually have the replica server, MyReplica, that is available, and we have replication that's occurring between these two locations. This is powered off, obviously, because we don't want to have two copies of this virtual machine on the network. So useful here to make sure that we don't end up, having IP conflicts because we get two servers running at the same time. When you do initiate replication, there's going to be a couple of additional properties that you might want to take a look at here under the settings for this virtual machine. When I turn on replication, there's a couple of new bits that are items that are added to the tree here under management for managing replication itself. We've already seen plenty of these. This has to do with the server we're replicating this VM to, the authentication type and the frequency, which recovery points we've configured, and then also the VHDs that are being replicated. But the last one down here is something that we haven't seen before. Resynchronization is a process that happens every so often on a replicated virtual machine. The resynchronization is really kind of a gut check to make sure that we're actually doing what we were supposed to be doing. We're actually creating a virtual machine that we can use over at the alternative site. And as you can see here, resynchronization requires some significant storage, processing, and network resources. So it's recommended for you to run that process after hours. So you may want to change the hours of the day that resynchronization actually occurs. When it occurs is handled by the replica server or by the replica services, but this gives you the ability to limit it to a very specific period of time. You also, up here under the network adapter, have the ability to identify the source and target IPs if if for some reason you need to bring up this virtual machine in an alternate location that has a different IP addressing scheme. So in your target location here, this is your IPv4 settings here. If in the failover location you're using a completely different network addressing scheme, well, it's here where you can identify what the settings will be. This will inject these IP address settings into the virtual machine at the moment that you pause replication and initiate a failover. So this will ensure that that virtual machine comes back online at the moment it comes time for it to begin working. So some nifty new added features here for you to look at. Like I said, I'd be aware of what these are. There is, I think over here on the replica machine, there is also a setting here for your test failover virtual switch. Now, in certain circumstances, you may want to actually test to see if this replication is working or not. All right, so let me draw here for just a second. So I've got, there's my site separation, and I got a virtual machine sitting over here, and I've got a virtual machine that's the replica virtual machine that's sitting over here. Well, when I want to test this site, obviously testing the failover requires powering on the virtual machine. And I don't want to power on this virtual machine and end up creating some name conflict between two different machines with the same name and the same services all on the network. So I have the ability here to identify what the virtual switch will be that I should power that machine on into. By default, the virtual machine is going to get powered on, not connected to any virtual switch, so it's completely isolated from your network. But if you really want to do some testing, you may need to create yourself a completely different virtual switch with different networking that will allow you to power on the virtual machine and perhaps connect it with a domain controller or other resources to do a true test of failover. Don't ignore this because it's easy to forget because it only is found here on the replica machine in the target location, not the source location. So these, be aware of these over on the target location. Now, for us to actually go through doing a replication, there are a couple of different kinds of replications that can, or excuse me, not replication, failovers. For us to do a failover, there are a couple of different kinds of failovers that can occur. There's a planned failover. So you know the hurricane is about to hit, and you go through all the effort before that hurricane hits to get your machines over into their alternate site. There's also an unplanned failover. An unplanned failover is something really awful happened and Denver is no longer on the map. Well, these two different types of replications are actually provisioned. The way that they're executed is done in very different ways. And a lot of that has to do with where you, specifically you, are probably going to be physically located whenever a planned or an unplanned failover is going to occur. A planned replication starts whenever I right-click here on the replica and I choose a planned failover. Now, remember, a planned failover, it's likely that I'm going to be in the source location, right? I'm going to be in the primary data center and not the secondary data center. Now, to do a planned failover, I have to actually power down the virtual machine first. So I have to make sure that that VM is powered off so that I don't end up having two VMs that are operating at the same time. Once that machine is powered off, then the planned failover will start the virtual machine, will complete the failover, will start the replica virtual machine, and then you can optionally choose to reverse the replication from that target location. So think about why this is a really cool idea. So in a planned failover, remember the idea is to keep these services up and operational no matter what. So in a planned failover, I have my primary and my replica virtual machines right here and right here. In a planned failover, the first thing that I'm going to do is turn off this machine, so it's powered down. I'm then going to initiate the failover to say you are now the primary virtual machine. This guy is now the primary virtual machine in his location, and so it makes sense for me to turn off the replication because now he's now the primary machine. But if as part of this planned failover, I want to make sure that the original machine is still getting the updates, I can then check this box to reverse the flow of replication during the process of that planned outage. Okay, so this gives me the ability to keep things working as I go through this planned failover. This is going to be very different from what might happen in an unplanned situation. Now, in an unplanned situation, something horrible has happened. The site is gone. The weather has, the hurricane has hit that location. Hopefully not Denver, because if we get a hurricane in Denver, that's really a bad day. So I am now in my alternate location like Las Vegas. And here in this other location, perhaps I need to go and initiate an unplanned failover, or what is called here just a failover. You want to know, I would be very aware of the fact that this word failover very specifically means an unplanned failover. That could be handy for, it just makes sense that this would be a test question about the difference between a planned and an unplanned failover. Also, what a test failover might be is something that I would probably want to do here from the target site as well. Now, in a failover situation, this failover situation assumes that the primary VM has failed. it also assumes that that virtual machine is powered off. So again, we don't want to bring that two VMs up at the same time. The neat part about an unplanned failover is that I can choose which of the recovery points that I want to use. So something bad has happened, so I need to initiate recovery, but I do it from the target side. So make sure you have that virtual machine powered off in the source location if you plan on doing a failover. The only kind of failover that you can do with virtual machines still running is a test failover. This test failover does exactly what you would suspect. It tests the failover, and then you can return that virtual machine back to its original location. But this is the only of the options that can actually happen when those virtual machines are both online. When you run a test failover, when you launch a test failover, it's going to create another virtual machine with a -test name. So you'll see another virtual machine that appears up here in the list. That gives you the ability to see if the virtual machine is operating. That virtual machine will exist in that test network that we created earlier, and then you can just simply delete the virtual machine whenever you're done. So again, this gives you that opportunity to create that test. Now, before you do any of these tests, it's generally a good idea for you to make sure that you have healthy replication going on between the primary and the replica VM. So make sure that you got it enabled. Make sure that you've got normal replication health here. You can look here to see what the size of the data that needs to be replicated, just the statistics associated with that data. And one last topic here as it relates to Hyper-V Replica between two standalone hosts is the idea of extended replication. So this new feature that is extended replication. I told you that extended replication is a way that you can create sort of a ladder or a series of replications between virtual hosts. So I start with 1 and 2. This is the initial replication. Extended replication takes me to host 3. The only thing you really got to know here is that all the other rules apply, except for the fact that the extended replication occurs here by choosing to extend replication to another machine. So there's going to be another wizard here that looks exactly like the initiate replication wizard that enables you to create that second hop. Most people implement these if you want to have perhaps a secondary backup site. Okay, so if you have to have really, really, really good support for virtual machines, you can have that. Or maybe if you want to have an archival copy of a virtual machine, just in case you end up with some weirdness. So all those are available to you. I want to talk only very briefly about how Hyper-V Replica works in a clustered environment, because most of the tenets of Hyper-V Replica are kind of the same in a clustered environment as opposed to a standalone environment. One of the biggest differences, however, is the addition of a replica a broker that needs to be added as a role here to the clusters that participate in a replica connection. And that replica broker is a role that you just literally install here, just like you would the other roles. Here is the Hyper-V replica broker role. We turn that on by giving it a name. I had a name here. What is the name that I gave and the IP address? All right, so I have to give it the name rep broker. And then I'm going to set that up on my one network here, which is, if you recall, is my production network. And the address that I have available is 224. So this could be anything you want, obviously, but just have to have a name for it. I would recognize what the names are of these replica brokers, particularly if you're going between a couple of clusters, because it's actually the client access point that's going to be the location that you point the replica to when you're doing replication between clusters. Okay, so not necessarily the virtual machine is the target location, it's the client access point is the target location for enabling replication. So here's rep broker. And that's set up for 224. I will confirm that, and it should end up creating this as a highly available service here on my cluster. There we go. This replica broker, again, it takes it does a lot of the work here as it relates to dealing with replication between multiple different clusters here. And the only thing, again, that you want to be aware of is if you initiate replication for a virtual machine between different clusters, come down here to enable replication and point this not at a virtual machine, but at the target replica broker, that client access point for that target replica broker. That's probably the important thing you need to know, because pretty much everything else here is exactly the same configuration wizard that you would see when you're doing standalone Hyper-V Replica. So that takes us through looks like the first couple of topics here as it relates to site level fault tolerance, the Hyper-V Replica, and extended replication. I got to now talk about this really really complex topic of multi-site clustering. And I want to try to focus you in on just the things you got to know for the exam, but also give you enough information that you might actually be able to create your own cluster if you felt the need to do so. I'm going to actually cheat in the creation of my cluster. And this is not anything you would do in production because, well, it wouldn't actually be the kind of cluster you would create in production. I'm going to assume that cluster 1, 2, and 3 are in the first site, and then 4 and 5 are in the second site. And in the correct configuration of this, I need to have some sense of cluster replication, or excuse me, storage replication between the storage that exists in both sites. So assume again, Denver and Las Vegas. However, I'm going to cheat here just simply because I don't want to have to incorporate any third-party replication technology. And I'm just going to point all these machines at a single SAN location. So they're sharing a single SAN. This I'm telling you so that you could potentially set this up as well if you want to demonstrate this at home. This is a way in which you can at least kind of play around with the extra settings that are required when you create multi-site clustering without all the added complexity of having to build in that replication piece, that third-party replication piece that sits underneath. So that's what I'm going to set up. And in fact, I'm going to pause things for a minute because I got to go through and actually pull the rest of those cluster servers into my cluster in order to be able to get this environment up and running. So hold that thought for just a second, and I'll be back here in just a minute with everything ready to go. And we're back. And in hindsight, I probably didn't actually need to go through the build of this entire cluster because we probably could have talked about a lot of these settings just on the whiteboard. But at least here you get to see the view that in fact I have connected 5 different servers together into a cluster. A couple of things that you should be aware of when it comes to multi-site cluster generation. I want to talk a little bit about Microsoft's recommendations for clusters, and then also just a few of the settings that you should be aware of. Now, I have a 5-node cluster here, and it is entirely possible for you to do a 5-node cluster, meaning an odd number of nodes. But the recommendation from Microsoft is, in fact, to use not an odd number of nodes, but always to use an even number of nodes that are split evenly among the 2 sites. So if you got 3 nodes in one site, you got 3 nodes in another site. Now, one of the reasons for using an even number of nodes is because an even number of nodes, when joined together with a file share witness, creates the best possible scenario for building a cluster that will automatically fail over should you end up with a big old site failure, which is the whole reason why you built this thing in the first place. Let's take a look at the reasons why this is the case. So let's assume that we have one cluster here, which is the Denver side of the cluster. We have the other side of the cluster here, which is the Las Vegas side of the cluster. And that we've also gone through the best practices recommendation. And in the Phoenix location, we've got our file server. So there's our file server. And on that file server, we have a share that we're using as a file share witness. This file share witness sits in the Phoenix site, which is a third location, a third geographic location from either of the 2 sites. The reason why this is the best possible configuration is because it protects you from the loss of either site, number one. It also automatically ensures that you have quorum at the remaining site, the surviving site, after the site failure occurs. So let's assume that, again, Denver explodes. Hopefully not, because that's where I live. When Denver explodes, let's look what happens. The moment that Denver explodes, you see how we have 3 nodes here and 3 nodes here. Because we have 3 nodes plus the additional vote that occurs here in Phoenix, we automatically have enough votes, 1, 2, 3, and 4, to constitute quorum. We've lost 3 votes, we have 4 votes, so indeed quorum is preserved. This is important because if we lose Las Vegas, we still have 1, 2, 3, and 4 votes as well. So when you're configuring sites, if you want to have automatic failover so that the site is automatically still exists, it still believes itself to be a cluster, it still preserves quorum, really the only way in which you can accomplish that and protect yourself from entire site failure is by ensuring you have even number of nodes in each individual site, and again, that file share witness that exists in that alternative location. Now let me contrast this with how you might configure that cluster in a different way, like what I've done here. With this cluster, I have an odd number of nodes, and so ostensibly we would be putting the first 3 nodes here into the Denver site, and then the last 2 nodes over here into the Las Vegas site. Now, in doing so, I will because it's an odd number of nodes, I'm going to be using the node majority model, which doesn't actually take into account a disk or a file share. And so I end up setting the cluster a bit like this, where I have 3 nodes here in Denver and then 2 more nodes sitting over here in Las Vegas. Now, this actually kind of creates a bit of a problem because we have to think again about the number of votes that exist in this cluster, even when it's spread across multiple sites. In this cluster are 1, 2, 3, 4, and 5 votes. Now, if I should lose Denver, boom, Denver goes away. Only 2 of the 5 possible votes remain, which means that as soon as Denver goes down, the cluster actually goes down as well because there aren't enough votes there for the cluster to consider itself still a cluster. What this means is that if you are interested in sort of protecting yourself, but at the same time not putting the same amount of hardware over here, and you don't want to use a third site, you're trying to save some money, you have no sense of automatic failover between these 2 clusters. And the only way to get this cluster back online is by forcing the cluster back online. Now this is the recovery of this cluster gets kind of weird in this situation because when that site fails, I've got some other things that I have to do. There is a website here you might want to take a look at called Force a Failover Cluster to Start Without a Quorum. And if I come down here and show you just the list of things you have to accomplish. Now, this is assuming that you've done something wrong and the quorum no longer actually exists on this cluster. The way in which you get those 2 remaining nodes back online is by using right here, start cluster node with fixed quorum, that fixed quorum parameter right there. That will force the cluster to start on the 2 remaining nodes. So at least you can get the cluster back online. And then the next thing you'll have to do is set the node weight to 1, for example, to guarantee that that node is a voting member of the quorum. That's this kind of little scriptlet down here. Be aware of what these are because although in the real world you're probably never going to set this up this way, that node weight is a way that you can kind of balance or unbalance how the different voting may happen, especially if you end up in a situation where you've lost a cluster and you have to recover that cluster. Now, notwithstanding, no matter how you end up building that cluster, there are also other configurations you have to lay into place as well. Remember that it is our mission to make sure that we fail over our virtual machines and our other resources within the production cluster first, and only fail things over to the backup cluster, the disaster recovery site, in those situations where something really bad goes on, like a site failure. So in that situation, it may become important for you to come over here to your resources and adjust some of their characteristics, specifically as it has to do with failover, like setting what the preferred and possible owners are here. Notice now that I've selected 1, 2, and 3 as the possible owners and ordered them appropriately so that I know I'm going to end up doing failover between those 3 owners, and then only to the remaining 2 owners when I absolutely have to. Now, don't get yourself in that situation where you end up failing something over to that remote site and you got to end up failing it back. Very important right here, so make sure you do that. Now, I believe we have one more topic here in this nugget, and it has to do with this Global Update Manager. And the only thing I want to tell you about the Global Update Manager is that I had to dig actually to find it, find really any information about it at all. And here in the What's New in Failover Clustering in Server 2008 or 2012 R2, this talks about the Global Update Manager mode. And the Global Update Manager is responsible for just managing cluster updates. And there are a couple of ways in which you can adjust how the Global Update Manager works. And this is another one of those. I just don't understand where Microsoft is going sometimes with these test questions. Because if you look down here, Microsoft suggests do not use either of the majority modes, 1 or 2. If you're really planning on doing, if you require strong consistency guarantees from the cluster database. In other words, if you want to make sure that your cluster database doesn't end up having any issues. So there are, again, for the test, there are 3 different values for the global update mode, all majority read and write and majority read write and local read. The way in which you define these is via the database read write mode property that's associated on the cluster itself. Other than that, I don't think you'd ever really touch this in any production world. So I give this to you because it says that it's needed on the test, but in the real world, I don't know if you're ever going to touch that much at all. So what have we talked about this Nugget? We've talked about kind of those two major use cases. On one hand, we have Hyper-V Replica, and Hyper-V Replica is a really nice way of taking two virtual machines and connecting them together in lockstep so that if one goes down, I can fail over to the other one. That can occur on standalone Hyper-V hosts, or that can occur between clusters. And in the second use case, we talked about multi-site clustering and how multi-site clustering gives you the ability to fail over those multi-site resources to an entirely different site as well. Two different situations, two different approaches, and two different ways that you can configure site-level fault tolerance. Coming up next, we're going to move away from virtualization all pretty much entirely and move ourselves back onto Windows Server just all by itself. Over the next series of nuggets, we're going to talk about some of these very advanced type things that you may or may not actually ever get to use in production, but are pretty cool new technologies that Microsoft has added here in 2012 and 2012 R2. The first of which is the nugget coming up next, has to do with Active Directory certificate services. And of all the new technologies I'm about to talk with you about, Active Directory certificate services is probably the one that you're going to want to implement, because with your own Active Directory certificate services infrastructure, you can build certificates in really whatever way you need to, for whatever purpose you need to, and it's at no extra cost. That's the topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.